Hello, in this video I'm going to solve the following problem for you. Let us read the problem first. Evaluate the following integral. Integral d theta over cosine theta times 1 plus sine theta. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, one possible answer that you might get is as follows. 1 over 4 ln of 1 plus sine theta over 1 minus sine theta minus 1 over 2 times 1 plus sine theta plus a constant c. Okay, now let us solve the problem. This problem is presented in the section in which the book is discussing the method of partial fractions to solve integrals. So this is why I will use that method to solve this problem. But of course, I will also present you another method to solve the same integral. Okay, method of partial fractions first. I first introduced this variable u. I would say let u be sine theta. My goal is to write my integral, so let me call it I, in terms of u. Before doing that, I multiply the numerator and denominator by a cosine theta. So this becomes cosine theta d theta. And the denominator becomes cosine squared theta times 1 plus sine theta. Okay, but then from here, I can calculate du, which becomes cosine theta d theta, which is good, because instead of this, I can put du, because my goal is to write the integral in terms of the variable u. But we also know that cosine theta squared can be written as 1 minus sine theta squared, but sine theta is u, so it becomes simply 1 minus u squared. So this integral becomes integral. Instead of numerator, I just simply put du, and instead of the denominator, I put 1 minus u squared multiplied by 1 plus sine theta, but sine theta is u, so it becomes 1 plus u. And this is a very standard problem in method of partial fractions. But you have to be careful here. The denominator is, of course, factorized. It is factorized to a polynomial of degree 1 and a polynomial of degree 2. But this polynomial of degree 2 can be even can be factorized more, so you have to do that. And if I factorize it, it becomes 1 minus u and 1 plus u. This 1 plus u, this 1 plus u becomes 1 plus u squared. So this becomes integral du divided by 1 minus u times 1 plus u squared. And now I use the method of partial fractions. My function that I'm going to integrate is this 1 over 1 minus u, 1 plus u squared. So I write it as a constant divided by 1 minus u, because 1 minus u is a first degree polynomial. The second factor is a first degree polynomial squared, so I have to introduce it in 2 steps. So I would say b over 1 plus u, and then finally another constant c over 1 plus u squared. And then I need to find a, b, and c. As usual, we multiply both sides of this equality by that expression. The right-hand side becomes simply 1, and then I have to adjust the calculations here. So the left side, I would write 1. The right side, what happens? This will be multiplied here. 1 minus u and 1 minus u are cancelled. 1 plus u squared is left, so it becomes a times 1 plus u squared. Plus the middle one, 1 plus u here, cancels one of these factors. This is left, that will be multiplied by b, so it becomes b times 1 minus u times 1 plus u. And finally, when I take this factor and multiply it here, this power of 2 will completely cancel that one. 1 minus u is left, which should be multiplied by the numerator. Yes? Okay, and of course I can expand this. So this becomes equal to a, it becomes the first one squared 2 times the first one times the second one plus the second one squared, and then I have b. This is the conjugate rule, so it becomes the first one squared minus the second one squared, and the last one I just copy and paste it, and then I expand, so it becomes a plus 2au plus au squared, and then I have b minus bu squared plus c minus cu. Finally, I will actually write this as a second degree polynomial in a standard form. So I have two terms involving u squared. I factor u squared, so then I will have a minus b u squared, and then I have this term involving u and that term involving u, so I factor u out, so I have 2a minus cu, and then finally I have three constant terms, as you see, a, b, and c, so it becomes a plus b plus c. Okay, so this is supposed to be identical to 1. This cannot happen unless I have a system here. This coefficient should be 0 because I do not have u squared terms. This coefficient, for the same reason, should be 0, but this coefficient should be 1. So I will have a minus b equals to 0, 2a minus c equals to 0, and I will have a plus b plus c equals to 0. But solving this equation is simple because from this equation I get that b is equal to a. From this I can get c is equal to 2a. And in the last equation, instead of a, I put a. Instead of b, again, I put a. But, I have written 0. This is not 0. This is 1. Okay, and then plus c. c is 2a. That is also 1. So this means that a is 1 over 4. If a is 1 over 4, b is equal to a, so b is also equal to 1 over 4, but c is double, so this becomes 1 over 2. So these are the numbers that I was looking for. Okay, so now the integral I that I am looking is this integral, but then this becomes this integral plus this one and plus that one, and a, b, and c are these numbers. So the integral I that I'm looking for becomes a, which is 1 over 4, integral du over 1 minus u. The next one is b. b is also 1 over 4, so it becomes 1 over 4 integral du over 1 plus u. And finally, I have c, which is 1 over 2, integral du over 1 plus u squared. But these are all standard integrals, so the first one becomes minus 1 over 4 ln of absolute value of 1 minus u. The reason that I have this minus sign here, because this is not u minus 1, this is 1 minus u. So this is the reason that I have a negative sign here. But the second one is just 1 over 4 ln of absolute value of 1 plus u. And the next one is also very famous, so it becomes minus 1 over 2, 1 plus u. And then I have my constant c. I can simplify that, for example, using this formula ln of a minus ln of b. It can be written as ln of a over b. Okay, so I factor a 1 over 4 out, so this becomes ln of this expression minus the ln of that expression. So I can write it as 1 over 4 ln of absolute value of 1 plus u over 1 minus u. And then finally I have 1 over 2, 1 plus u, and then I have c. But I have to switch back to my old variable theta. U is this expression, so it becomes 1 over 4 ln of absolute value of 1 plus sine theta over 1 minus sine theta, and then I have minus 1 over 2, 1 plus sine theta, and plus my constancy. So this is the answer that we get for this integral. But you know that sine theta is between minus 1 and 1, So 1 plus sine theta and 1 minus sine theta are both positive, so we really don't need this absolute value sign, so we can replace it with actually pair of brackets. So let me just do that. Okay? Okay, now in this part of the video, I want to convince you that these two answers that we got in different ways are either identical or they differ by at most a constant. Okay, so let me just call this part, for simplicity of writing, A, and this part B, and then try to simplify them individually. So my goal is to simplify this answer and to see if it can match with the previous answer. So A is equal to. So if you see here, I can factor 1 over 2 tan theta out. Yes, so I would say 1 over tan theta. I open a pair of brackets. From the first term, only secant of theta is left. And from the second one, I have minus tangent theta. Okay, so if I simplify this a little bit, so it becomes 1 over 2. Instead of tangent, I put sine theta over cosine theta. And then instead of secant, I put 1 over cosine, and instead of tangent again, I put sine theta over cosine theta. And now what happens in here, the denominators are the same, and I have also a cosine here, so I multiply them. So the denominator becomes 2 cosine theta squared, and the numerator, I just write them as this, sine theta multiplied by 1 minus sine theta. And what I want to do, instead of cosine theta squared, I would write 1 minus sine theta squared, and then I use conjugate rule to factorize it, yes, as this expression. So what I want to do, I want to replace this with that expression here. So this becomes equal to sine theta, and I have 1 minus sine theta. And in the denominator, as I told you, I have a factor of 2, and of course I have 1 minus sine theta, 1 plus sine theta, yes? This is what I have. But now you can immediately see that this factor and that factor are gone. What I get is sine theta over 2, 1 plus sine theta. Okay. So you might find a little bit of discrepancy here. So you see that this expression is similar to this part, but not exactly that one. But that is just superfluous. So what we can do, we can say instead of the numerator, I can write 1 plus sine theta, yes, and minus 1. And then divided by 2, 1 plus sine theta. And then what happens, I can say that this expression divided by that, which gives me a factor of 1/2, and then minus this expression divided by this. So it becomes simply 1/2 minus 1 over 2 times 1 plus sine theta. So that is good. You see, this expression that appears here is not identical to this expression, but it differs by that expression only by a constant factor of 1 over 2, which is as we could in principle predict. Yes, these two answers should be either identical or they have to differ by at most a constant. But now let us convince ourselves that the second part is identical to the first part of this answer. How? Let me just do it like this. So I would write 1, so let me write B is equal to 1 over 2, ln of absolute value. Instead of secant, I can write 1 over cosine, and then I have plus tangent, which is sine over cosine. Yes. Okay, what can I do now? I can write 1 over 2 ln of 1 plus sine theta over cosine theta absolute value. Yes. But of course, here again, the numerator does not need any absolute value signs. Only the denominator needs that. But let us keep it like this first. But the point that I want to do is that I would write 1 over 4 instead of 1 over 2. Okay, and then I would write ln of 1 plus sine theta over cosine theta squared. Okay, Why is that? Because this 2 goes back to the ln, and then that 2 and this 1/4 gives me the same factor of 1/2. So what we have done is correct. Now, what will happen here? I would write 1/4, and then I raise this one to power 2, and I raise this one to power 2. So this becomes ln of 1 plus sine theta to the power of 2 divided by cosine theta to the power of 2. But again, the same trick. Cosine theta to power 2 is 1 minus sine theta to power 2 is 1 minus sine theta cos 1 plus sine theta. Yes? So I would write 1 minus sine theta, 1 plus sine theta here as well. Okay? And now you see what happens. One of these and this are gone, and I get exactly the same answer here that I am supposed to write. Yes, so it becomes 1/4 ln of 1 plus sine theta divided by 1 minus sine theta. Okay, so yes, that is exactly this part of this. So it means that this b is identical to this part, but part A is this plus 1/2. So in total, this answer that we got from the second method differs by this answer we got from the first method, just by a constant additive constant 1/2. So everything is in order. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.